here you have the function A equals half AB sine C. You might remember this as how you calculate the area of a triangle when you have two sides, A, B, and the angle between them. Alright? But anyway, you're asked to find the total differential of A, which is dA. Okay, now, the total differential dA. Remember, you're going to have this small change in A. As a change in A is going to be the rate at which one of these variables change time with respect to A times a small change in that variable plus and the next and the next. So in this case we have well, it will be partial of A by partial of the area of the triangle big A by partial length of one side small a times that change in A, right? That small change in A. Now let's write it as dA, because we're given dA. Alright. Oh my. Small a I should write dA, right? Because we're given D in the last part here. Alright. But this would still be a small change in A plus the partial derivative of the area with respect to the length of the side B times a small change in B, right? Plus partial derivative of the area with respect to a change in the angle C times a small change in C. So for part A, that's what we have there, the total differential. Now, part B, the length of A is 150 arc in this case. The unit given, it could be meters, feet, and so on. Alright, so it's feet. And the error is plus or minus 0.5 feet. The margin of error. B is 200 plus or minus 0.5 feet. C, the angle C is 60 plus or minus 2 degrees. Alright? So what we're going to do, what we should do, find the average value, and then we find the range, the error in the area. All right, so here now the average value for part B. So when we're done, we're going to put that average value plus or minus that margin of error in the area. So it's going to be half A, which is the average of A is 150, half times 150 times B, which is 200, times sine 60. In this case, when we calculate it, what do we get? Let's get our calculator here. There's a calculator. Calculator. Alright. So we have a calculator here. So 0.5 times 150 times 200 times the sine of 60 degrees equal. So you have 12,990 then. Right? So it's 12,990 square feet then. Alright? Now, here, we're going to need to do some differentiation. We're going to find partial derivative of the area with respect to the length A. So, partial area by partial length A equals, in this case, it's going to be, you use the power rule, and delta A by delta big A, area, by delta small a, the length is half B sine C. It's going to be half B sine C, right? Then we find delta A by delta B equal. So here, power rule again. These multiply the B, and the B is raised to the 1. So when you multiply by the power of B, which is 1, and reduce the old power by a new power, 1 minus 1b to the 0, which is 1, you get half A sine C. This is going to be half A sine C. And then partial of A with respect to C is going to be what? Well, you have something multiply sine C. When you differentiate sine, you get cos. So it's going to be half AB cos C. Okay? So now, the thing is, when you work out any small change in the value, your angle must be in radians, alright? Has to be in radians. Now, remember that if I had put a calculator in radian, convert this to radian, and find the sine, I will get the same thing. Same thing as when I have the calculator in degree, find the sine of 60 degrees, right? Alright. Now, here, we're going to convert in order to find the change and so on. We're going to convert the thing here, the angle from degrees to radians. Now, you're going to have your delta A by delta A dA. In this case, dA is going to be 0.5, right? So what you have is that dA, let me rewrite, that dA is going to be partial of, with respect to A, which is half B sine C times dA, which is 0.5, plus the A by delta B. Oh, by the way, I'm going to, oh yeah, yes, did it already. Partial A by partial B is going to be half A sine C times dB is 0.52 plus, and then partial A by partial C, which is half AB cos C times, alright, DC for now, because when you're ready to put in the values into the function, they're supposed to be in radians. Remember, the degrees come from the historical use of base 20. That's one argument as to where it come from. The other one is it was estimated that you had 360 days in a year, right? That's another argument. But the radians, where the radians come from, is actually from the dimensions of the circle. If you have a circle and you have the radius, when you open 2 radii so that the arc length is equal to the radius, that's 1 radian, right? So that will give you the proper value when you're dealing with margin of error like this. So 60 degrees plus or minus 2 degrees. Now, how do we convert from degree to radian again? Remember, the circle contains 360 degrees. Now, the circumference is 2 pi r. And as I said before, when you open to 1 radian, then what you have is, this is 1 radian. What you have is the arc length is equal to the radius. So they call it the radian. Alright? The arc length is equal to 1 radius. So in this case, 360 degrees is equal to 2 pi radians. Alright? 2 pi r. So 180 degrees is equal to pi radians when you divide both sides by 2. We want degree to radian. 1 degree would be, just divide both sides by 180, you get 1 degree on the left, and on the right you get pi over 180. Alright? So 1 degree is this. Then you turn the 1 into 60. 60 degrees. Just multiply the 1 by 60, you get 60 degrees equal. Multiply the right hand side by 62, you get 60 times pi over 180. This would amount to what? Cancel down 16 to 83. So it's going to be pi over 3, 1/3 pi radian. Alright? So 60 degrees, 1/3 pi radian. And then you have the margin of error, which is, what was it again? 2 degrees. So 2 degrees is equal to, is going to be 2 times pi over 180, which is what? If you cancel down, right, it's going to be pi over 90 when you cancel down. Alright? So here now, the DC is going to be pi over 90. Alright? That's a change. 2 degrees. It's pi over 90. When you use the calculator, we'll turn those into numbers instead of the third form with the pi over this and the that. Alright? Instead of the exact form like this. Alright, so here we need to put in the values. So dA is equal to, alright, this is going to be half times B. B was what again? B was 200. Half by 200 times, no, this is sine of C. the angle C is pi divided by 3. So it's pi over 3 times, and then you have the change in, where is it again? Yeah, 0.5, the change in A. A and B have the same change, which is 0.5, right? Plus half times C now. I think C was, no, not C, it's not C. I'm not ready for C yet. I just did half B sine angle C, right, times 0.5. Yes, it's A. A was 150. So plus half times 150 times sine C, which is pi over 3, right, times 0.5 plus, and then half times A, which is 150, times B, which is 200, times cos C. The angle C was pi over 3. Times, and then the change in the angle, right, is pi over 90. Do you see that? Now, this dA is equal to, we're going to do calculations now. Let's get, I have that calculator, but I think there's another calculator that I might use because oh, this is calendar. I'm more comfortable with that other calculator, knowing that I'll be confident as to whether it is in degree or radian mode. Calculate. Oh, it's not that one that I want. It's which one? Where is it? Okay, yes, this is the calculator I was searching for. Alright, so here, click this, and I know it is in radian mode. If you put it in degree mode and say 30 sine, you're supposed to get 0.5. And when you put it in radian mode and say 30 sine, you're not supposed to get 0.5. It's that you're supposed to get. So that's one good way of checking whether your calculator really is in radian mode. If you haven't been accustomed to using that calculator, you just got it or just borrowed it, you have to be sure. Alright, so half times 200 is 100. 100 times pi over 3. Alright, let's clear it and just deal with the pi over 3 business first. Pi over 3 equal. Oh, what's going on? Clear. Pi divided by 3 equal. Okay, so that's what you have there, 1.047 times 100 equal. So you have 104 point that, then times 0.5 equal. So in that case you have 52 point something there, right? So that's 0.5 by that. Let's do it again, make sure we didn't make any mistake, right? So we have pi over 3 equal that. And then sine of that. I didn't remember seeing this. I made a mistake, you know. Yeah, I'm supposed to find the sine of that. Right. The sine of 1.047. Right. Times, then you have half of 200 is 100 times 0.5 equal. Right, so you have 43.3 for that part, 43.3 for that part, plus. Alright, so we get back to the calculator. Let's see what else we have here now. We have pi over 3 again. Pi divided by 3 equal. Okay. Then sine. Sine. Good. Times 0.5 equals. Times 150 times 0.5. Alright, so we get 32 point something. 32.48. 32.48 plus, and this part out here, let's work that part out and see what we get. Back to the calculator. We have pi over 3 equals, and then cos that is 0.5. So we have this part taken care of. This is half of, let's just multiply it out as it is, times 0.5 times 150 times 200 equal. We have that, right? And then finally times pi equal over 90 equal. So now here we have 261.8. Alright, so this add to 261.8. Okay, so BA is equal to that. Change in A is going to be equal to the 261.8 something here plus 32.48 plus 43.3 equal. So we have 3, call it 338. 338. Since our measurement was in feet, this area would be in square feet. So the area then is equal to where's the thing again? That I calculated. We calculated the area. I think it was 12,990. There is 12,990 plus or minus 338 square feet. Nice. So you see that. Alright, so I'll see you in the next video.